So here's a bit more on probability. So when we look at probability, there are two types of things that could happen. So we can have independent events. So that's when you have two or more things where the outcome of the first event doesn't influence what happens after that. And when that happens, you're just multiplying the probabilities together. So some examples of independent events: flipping coins, right? You flip it once, you flip it twice, you flip it 3 times, doesn't matter. Every time the probability is a half, a half, a half. A rolling dice, those are independent. Or even like a game where, if you roll a dice and you get a certain color, those are independent. What you roll in the dice doesn't impact the color that you're going to say spin on a wheel or something like that. So those are called independent events. So let's have a look at a possibility of an independent event. So for example, let's look at something like you win a prize if you can get heads, I don't know, 3 times on a dice. So the probability of heads once is 1/2. So we could actually do this as a tree diagram if we wanted to, heads and tails. And then on our second flip, we could also get a heads or tails, or a heads or tails if tails came up. And then on our third flip, we could get heads or tails, heads or tails, heads, tails, heads, or tails. So when we look at this, we actually now have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Out of those 8, we only have one outcome where all heads would show up, for example, and then we win the prize. So the probability of getting 3 heads in a row would be 1/8. Now, another way of showing that would be, so the probability of 3 heads, let's say. And that isn't written very well. That's supposed to say heads. Okay, so that's going to be the probability of heads times the probability of a heads times the probability of a head. So when you have independent events, you can just find the probability and multiply them. So the probability of a heads is 1/2. The probability of a heads happening again would also be 1/2, and the third time would also be 1/2. When we multiply those, we get 1/8. So if we go back to this formula here, how do you calculate the probability of independent events? Well, you just take the probability of the first event, you multiply it by the probability of the second event, or the third event, fourth event, etc., if there's more events. So that's for events that are independent. What happens when the outcome of one event does impact the outcome that happens after that? We call those dependent events. So for example, if I were picking cards out of a deck of cards, and I wanted to find the probability of drawing, say, 2 kings. So the probability, so first of all, a deck of cards has 52 cards. And in those 52 cards, there are 4 kings. So the probability of drawing 1 king would be 4 out of 52, which simplifies to 1 out of 13. However, if, say, I draw a king, now I only have 51 cards left in my deck. So now instead of the probability of a king being 4 out of 52, if I already take 1 card out and it happens to be a king, now the probability of drawing another king, there's only 3 kings left, so that's 3. And now there's only 51 cards left, so that's actually 3 over 51. So now the probability of that second event happening won't be quite the same as the first event. And so when we do dependent events, the formula that we follow is same as the first bit, probability of event 1, like we had with independent. But here's the difference. The second thing is the probability of the second event happening after the first event happens. Another way of writing that would be something like, so say the probability of A and B happening would be the probability of event A times the probability of B after A. That notation, you'll see that sometimes with a little line in between. So let's look at that again as an example. So let's take that example of the probability of getting 2 kings. So this would be if I'm not replacing the cards. Now, if I was replacing the cards in the deck, so I drew a card, it was a king, I put that back in, I draw again, then these would be independent events. So anytime you replace the card and you go back to 52 again, they would be considered independent. But if you take the cards out and don't replace them, then they're considered dependent. So again, let's go through that example. The probability of getting one king is 4 out of 52. Simplifies to 1 out of 13. Now, the probability of getting that second king, we only have 3 kings left, and there are 51 cards left. And so we would multiply those, and we would get 3 over 663. And that would be the probability of drawing 2 kings in a row. And then, of course, don't forget that you would simplify that to 1 over 221. Now, let's look at one more example with that. So, for example, say you have a bag of marbles and you had 2 blue and you had 3 red in it. And you might want to know the probability of getting 2 blue marbles pulled out in a row. You could also do this in a tree diagram format where you could say, okay, the probability of pulling a blue versus pulling a red. So if I pulled a blue, I guess I should have done that there, but that's okay. I would now have 1 blue left and I would have 3 red left. And the probability of doing that would be 2 out of 5, and that didn't show up very well. Now, a red, if I pulled a red, I would have 2 red left and I would have 2 blue left. And the probability of doing that would be 3 out of 5. Now, what's the probability then of drawing a second blue out of that? So let's say we have a blue again. I now, if this is my picture, I have 1 blue and 3 red. The probability of getting that blue is now 1 out of 4, which is different than my original probability of a blue. I could have also drawn a red from there, and the probability of that happening would be 3 out of 4. Likewise, down here, I could draw a blue, and that would be 1/2. Or I could draw a red, and that would also be 1/2. And so now if I wanted to calculate some of these probabilities, like, for example, and I should have made that one blue. I'm going to make that line blue now. If I wanted to calculate the probability of 2 blues in a row, 2 blues in a row would be 2/5 times 1/4, or 2/20, or 1/10. I can also calculate other things, like what's the probability of a blue and a red. So that would be 2/5 times 3/4 plus 3/5 times 1/2, because there's actually 2 possibilities of a blue and a red. Or the probability of getting 2 reds in a row would be 3/5 times 1/2. So I can use tree diagrams to help me as well. And again, coming back to this formula, probability of dependent events, so things like drawing cards where you're not replacing, or like pulling marbles out where you're not replacing the marble after you take one, is the probability of the first event multiplied by the probability of the second event happening after the first event already happens.